I want to talk about building WebRTC products and how I ended up finding bugs basically everywhere. So I'm Philip. I work for Appearin, which is a Norwegian company. We're part of Telenor, the biggest telco in the Scandinavian countries. I also write a lot on WebRTC hacks with Chad Hart. And Appearin is one of those WebRTC things that are basically this one click, send a URL to someone, and then can easily join within a matter of seconds video chat services. It's a free service. It was launched in 2013. It was originally written by a couple of summer interns, and it has evolved a lot since then. It is using full mesh, so everyone is sending to everyone else. Emil calls that full mesh. We're a little smarter than most full mesh services, so we make the bandwidth depend on the number of participants, because otherwise Chrome will just try to pump out 2 megabits per second to every participant. And most upstreams don't deal well with 12, 16 megabits upstream. So we do have SFU support coming to support the use case for up to like 20 participants, because full mesh is limited. We get it to around 8 people, but then it starts breaking down. So WebRTC, it's now 5 years old, and it's still not done. I mean, it's a hard problem, so no surprise here. I mean, there are browser differences. You can use adapter.js to hide them. There are differences in the API. The WebKit RTC peer connection in Chrome needs to be shimmed. You need to deal with all that small differences. You have differences in the SDP in Firefox. When you have multiple streams on a peer connection, you have something called unified plan. In Chrome, you have something called Plan B. And back in 2013, there were plan wars. And you also have a very different user experience in the browsers. So the get user media call looks different in each browser. And spec compliance is a huge problem, because the spec is still changing a lot. And the browsers are not quite good at catching up with those changes. And of course, we see lots and lots of bugs. And we see a lot of platform instability, and I've seen a lot of that. So for example, back in 2014, I found a Firefox bug where Turn did not work on Windows at all. And nobody noticed for a couple of months. In January 2015, we saw that a Chrome 41 upgrade almost rolled out and broke every DTLS connection with the Jitsi video bridge. We caught that barely in time before it rolled out, and Emil could fix that stuff. In March 2015, we saw Firefox 38 requiring perfect forward secrecy for DTLS, which broke Talkie.io, the native apps, Appearin native apps, even Facebook Messenger. And it continues. In December 2015, we saw Chrome 47 rolling out, and we saw a huge increase in ICE failures. I'm going to touch that later. In February 2016, Chrome 48 fixed a bug where they had a video delay built up to 10, 15 seconds, so a lip sync issue. In July 2016, Chrome 52 just rolled out, and it switched to ECDSA certificates, which broke some people's infrastructure. And just last 2 weeks, I found a bug in Firefox 47, which breaks Turn TCP on Linux. So browser updates break things every 6 weeks, and it's quite stressful. So this video desync issue, we saw that we got customer reports. I was working at TalkBox back then, which is one of the largest platforms. We saw people reporting a growing video delay, and most of them were down in Australia, and we thought, oh, bad internet down under. And it turned out to be a change in Chrome where they changed how they do the timestamps from the cameras, and it caused this clock drift and a linear, almost linear increase in one of the metrics, which was Goog min playout delay milliseconds. And we had to dig the source code to find out what that means even, because it's not documented. And it broke AV sync completely for an unknown number of clients on Windows, which is the largest platform for Chrome. And they did the right thing and reverted that behavior change all the way back to Chrome stable, which I've rarely seen them do. But they handled it quite well. It was caused primarily on Logitech C930 cameras. They do a lot of testing, but they didn't test with this particular camera model. And I just checked numbers. It's 0.4% of our users at Aperion have this camera. So it's very hard. We have like 2,000 different camera models, and I'm surprised WebRTC works at all with such a large number of devices. And at the same time, to make things more difficult, it was not just on Windows. We also saw a similar issue on macOS. And it's really hard to get concrete data for those user reports. Like, it took us 2 weeks to get this graph we saw earlier, to get the data for that. And then figuring out the right metric to look at, we didn't even know what this particular metric was doing before. We found out the hard way. And we thought, can we prevent this in the future? We don't want to do this again. It was hard to figure out. So maybe we can do something more proactive and monitor everything and maybe write something that allows us to say, get me all the sessions where the maximum of this Goog min playout delay milliseconds is bigger than 1,000 milliseconds. And then look for pattern, like it happens mainly on Windows. It happens very often if this Logitech camera is involved. It also happens on OS X, but less often, so it's not always there. It might be different bugs with similar effects. And as a result, we started gathering 300 features of a session. Lots of stuff like bugs we've seen in the past, timing stuff like the different time difference between get user media call and the result, and also a lot from the getstats API we just saw on the Chrome WebRTC internals page. And we're taking those session features and turn them into platform metrics, like how many ICE calls fail per day. And we do that with a nice SQL interface. I like that a lot. We also do it with Elasticsearch and Kibana for really fancy graphs. And that is quite useful, not just for finding bugs in browsers, but also for pushing your product. And I want to show you some examples of that. And one of the most important questions is it a bug in the browser, or is it a bug in your code, which is that you're using the WebRTC API in a wrong way? That's quite hard to figure out sometimes. So I have 3 main examples. One is get user media dialogues, ICE failures, and then how we do turn deployment using that tool. So the get user media dialog is very different in the browsers. In the top left, you see Chrome, which has a pop-up. Next to that is Firefox, and then at the bottom, we have Opera. All 3 are very different. If you have Microsoft Edge, it has the same dialog at the bottom, completely different user experience. And there are 2 things I looked at. And one of the questions was, how long does the get user media call take? And the other one, how often does the get user media report result in an error? For example, the user rejecting the permission. And I did get user media timing for Chrome and Firefox and was quite surprised with the result. So you have to know Chrome persists the permission. It only asks you once. If you allow, then it stores that permission. Firefox, by default, gives you a choice and lets you accept things. They have a pop-up which allows you to permanently accept, but it turns out the red graph is Firefox, and almost nobody uses that. Whereas in Chrome, it takes less than 100 milliseconds for 50% of the users. In Firefox, it takes them about 3 seconds. And that is some kind of feedback that I showed to the Mozilla people, and they were, oh yeah, maybe we should take that into account when redesigning our stuff. So looking forward to that. And the other question is, how often does get user media result in an error? And I looked at 100,000 calls, and we had a shockingly high number of 5% permission denied errors. But don't quote me on that, because during the week it's 3%, and on the weekends it's 8%. A lot of that depends on user behavior and how we have different types of users during the week and during the weekend. We still allow them to participate, but it's very hard to get out of this permission denied state. And I tried to reproduce that. I denied permission, which is in the Chrome address bar on the right side. You can revoke permissions. OK, I was testing some stuff. Then I had a call with a coworker, and I re-enabled the permissions and spent 5 minutes figuring out why I didn't get audio. And it turns out that I unblocked the camera, reloaded the page because Chrome requires me to, and I had forgotten to unblock the microphone because the UI didn't offer me that option. And it was because we did some silly fallback, which was written by the interns. We blame also back code on them, back in 2013. And at that time, the errors in get user media were not well defined. They differed a lot between browsers. So we did some stuff. If we had an error while calling with audio and video, we fall back to audio. If we get an error calling get user media with audio only, we fall back to video only, and otherwise we just give up. And unfortunately, what Chrome does in this permission UI is that it takes the last get user media call into account. And if you go to Emil's Meet Jitsi, then you get into a state where you cannot re-enable the camera. And that is quite silly from the Chrome UI in that case. We fixed our behavior, but I still filed a bug and told the Chrome people that this is not good. So why do we get those permission denied errors? I mean, we are based on sending this link to someone else, and then they come to our page the first time, and they get this pop-up. Do you want to allow camera access for a peer-in? And most of the time say, no, I don't want to allow this site to get access to my camera, because they don't understand that we're a video chat site and that they just got invited. And that we had the hypothesis that this causes them to deny permission, and then they don't get out of that state. So we did an experiment. We tried to explain it better. We added another button for the first time user experience where we asked them to click a button we control before showing the browser pop-up. And that worked quite well. We did that last week, and the permission denied rate dropped down to 6% from 9.5%, which is good. However, it is not as much as I expected. And it turned out that we showed that dialog not only to new users, but everyone who had ever denied permission. So we need to repeat the experiment and take that into account. Doing those experiments is incredibly hard. If you don't get the details right, you have a problem. And another thing we saw, we are not going to do this in Firefox, because as we saw earlier, Firefox users don't persist the permission. They just don't like to. And doing that would force them to do 2 clicks, where previously they just needed 1 click, and that would be very annoying. So we are only going to do it in Chrome. So some takeaways from this. Do not trust any numbers without context. Don't quote me, please. You should design for the browser user experience and also the browser user behavior, because that is different between Chrome and Firefox. And you should use one get user media call for both audio and video, even though some people say otherwise. OK, ICE failures, one of my favorite topics. Are you with me, Emil? So I read on No Jitter, which is one of those VoIP analyst pages, that 20% of WebRTC calls fail, which was later corrected to 12%. And I made some fun of someone on the WebRTC team and told him, hey, you're doing a bad job. And he said, if 20% of your calls are failing, maybe it's time to consider a career change. OK, maybe I should consider a career change. Let's check my numbers. So you have this platform metrics. I looked up our numbers, and it had 6.7 calls, which went to an ICE connection state of failed, which is bad, but better than the numbers I saw. And fortunately, I know all my bugs, because back in December, we saw at TalkBox this huge increase while Chrome 47 was rolling out. And we had like less than 0.5% of calls failing before. And that increased to 2 or 3 or 4% when Chrome 47 rolled out. And it turned out that this was not actually an increase in failures, but only connections go into the failed state. So they were already disconnected, and then they went to fail, which is a slight improvement, but it changed our metrics completely. And if we take that into account, this 6.7% go down to 1.9%. And again, that varies greatly between weekday and weekend. So if we drill down even further and take a look whether we could get the relay candidates. So if we can't get the relay candidates, we're on a blocked network. And we can explain 60% of the calls that fail that way. 40% are still unaccounted for. Chrome and Edge are adding counters to help debug that further, because we need to get it down to like 0.1%, hopefully, to make WebRTC work really well. And I mean, those numbers are very, very service specific. So in the no jitter article, apparently that was mixing up services which run turn servers and services which don't. And for example, we used turn on UDP, on TCP and TLS. It probably depends on what port number you run turn servers on. It depends on full mesh versus SFUs. Even if you look at SFUs, you can't compare SFUs that use one connection with multiple streams versus SFUs that do multiple streams on the same connection. And the browser telemetry, they have that, but it's very hard because they get a lot of noise, because so many different behaviors. And it's really hard to compare numbers. Gustavo Garcia from TalkBox and I tried, and I know his platform really well. We have a common tool. We look at the same metrics, and we're both interested in whether something is a browser or platform issue. And even we found it very hard to compare numbers. And both of us need to establish baselines for what is normal for our services, for the way we use WebRTC. And then we can talk about whether we see an increase compared to our baseline. And another example is this. So Firefox 47 rolled out, and I ran into an issue. I was testing something, and I tested with our usual turn appear in, 443, transport TCP. And typically, I use a Linux machine, and that didn't work. And yeah, why didn't it work? I tried with an IP address, and it worked. What the heck? And it affects us a lot since we use DNS to resolve the closest turn server. And I found that manually. And I looked at our platform data, and it turned out that the success rate of turn TCP on Linux is 10 to 20%, whereas on Windows it's 90% plus. So it is specific to that platform. I found a bug. The Mozilla people took it serious. They had a fix within a week, I think, and then uplifted it all the way to the stable stuff. It was a regression 47 recently introduced. We could have used some kind of outlier detection to detect that earlier, because it was there for 2-3 weeks maybe. And I want to get to the state where we just tell browser vendors, look, metric changed. Look at this part of your code. Something changed, and it shouldn't. So takeaway. You should measure and drill down into the numbers. Just don't take any number like 12%, 20%, and it doesn't make sense. You need to talk about what you're measuring, where you're measuring. You should establish hourly, daily, weekly baselines. You should look for outliers and trends, like an increase in ICE failures. Might be a bad deploy or the browser rolling out. And feedback to the browser vendors is really important. They fix stuff if you tell them that something is broken. So last topic, turn deployment for a peer-to-peer service. So we use full mesh. We're fully peer-to-peer currently. We use turn, UDP, TCP, TLS, all running on port 443. And 30% of our calls are relayed, which is a bit higher than what I hear that the average is. And it turns out there might be a reason for that. So sometimes Chrome uses turn even though stun is sufficient. We found that manually during testing, and it's hard to say how often that happens. I mean, sometimes it works, it uses turn, and when we disable the turn service, it still works, and that should not happen, because turn should just be used as a last resort. It seems to be timing related, so very hard to reproduce, and it costs us a lot of money. Turn is one of the major parts of our infrastructure cost. Well, every month we pay money to Amazon because of that. Thanks, Google. So I read another article on NoJitter about the way that Cisco deploys Spark. And it was quite interesting. They showed a coverage map of data centers, and they said that they have a goal of sub-100 millisecond latency for every participant in a conference. And that sounds quite ambitious. So I was like, OK, can we measure something similar? And we tried to relay calls through servers close to the users, and we're deployed in 11 data centers around the globe, which is easy on AWS. So what metric do we use? We use the connection time. And my coworker looked into the numbers we have, and on the left you see how the connection time varies for stun connections, so connections that are using peer-to-peer without a relay, and on the right you see using a relay. And on the right we see two peaks. One is for turn UDP, the other is for turn TCP, which takes a little longer. And the problem with that metrics is if you have two clients from different regions in a call, it is very hard to isolate that turn server used. So instead, we looked at the time it takes to gather the candidate. If you call set local description in the peer connection API, it starts ICE gathering, and then you wait until you get a on ICE candidate event with a relay candidate. And you measure the time that gives you an estimate for how long 2 round trips to the turn server take. And you can split that by data center. I have a blog post on that, and we see that we are pretty good in Oregon and pretty bad in Singapore and Mumbai. Almost double the latency there. And we intuitively got it right. We have a 99 millisecond to 166 millisecond median round trip time, which is pretty good. But it's a lot influenced by the distribution of users. For example, Frankfurt has pretty good networks, but we have a wide circle of users and speed of light. We see a lot of bad networks in Southeast Asia and India, which is expected. We knew that AWS is not as good down there. And one of the interesting things was that the Firefox median was consistently 20 milliseconds higher than Chrome. And I'm talking with them, and they're quite interested in that kind of metrics. And we can do more experiments. We can compare different cloud platforms like AWS versus GCE and choose where to run turn servers. We can also compare software like we use currently Coturn. I prefer ReStandD. We're going to benchmarks that way. And then we can figure out what really works. So takeaways, again, measure and then drill down. Again, establish those baselines for your service so you know what is normal for you. And you can use such a tool to choose the locations for your turn servers and your data centers. So that's it almost. So if you want to have a few key takeaways, take this: measure, rinse, repeat. Do this kind of performance engineering. It has a lot of impact on your product, like the get user media stuff, on your user numbers, on your user experience, on your platform, and also on the browser vendors. You can help them catch bugs because the Mozilla team is very small, just a handful of people, and they have 1,000 companies using WebRTCs. They need a little help. They need feedback, and they're happy about it. And having the right tooling is incredibly important. Like, since we have that tool deployed, I find more bugs even. At least I'm not unprepared anymore. That's it. If you want to find me on the web, just ping me there if you have questions. I think we're going to do Q&A in the hallway, right?
No, we've got time for a question or two.
Good.
Got arms popping up all over the place.
Thank you for the very interesting presentation. And can you elaborate on percentages and also causes why your clients must use a turn server to reach you?
Well, there are some reasons to run. I mean, some clients are in networks where UDP is completely blocked, and then they need to fall back to well, because it's corporate networks. One of the biggest causes of failure there is authenticated proxies. So Chrome does not support proxies that require authentication. It has been an open bug for 2 years. It's the most starred bug, and they just say, we don't have time for it. and it costs them, they estimate 500 million minutes per week, and it costs them like 10, 15 million minutes per week. Okay, if you don't want to fix that, I think you should prioritize it, but I don't know. Yeah.
The question is, you tunnel TCP on 443. Okay.
Philip, that was very impressive presentation. Is that your way to scare off your competitors?
Well,
That's a
good
long
luck.
list of issues to drill down.
Yeah.
Very nice.
I'm talking about the issues. I'm not telling you how great WebRTC is, how great it works, because it doesn't yet. But
Thank you.
we're getting there.